Have you ever just looked up at the night sky and felt, well, a mix of total wonder and maybe a little bit small? We're about to go on a quick journey to really, truly understand our place in the cosmos. It's going to be fun. So let's kick things off with, maybe the biggest question there is. What is our place in the universe? For thousands of years, people have stared up and wondered. But today, we can actually answer it. We're going to build our cosmic address, starting right here at home and working our way out.
All right, Section 1, your cosmic address. Let's start with what we know best and zoom out, step by step.
Okay, first line of the address. We live on a planet, Earth. It's a pretty big object, sure, but the key thing is it orbits a star. And here's something to remember. Planets don't make their own light. They're basically cosmic mirrors, just shining by reflecting the light from their local star. And that, of course, brings us to the star itself. Our star, the Sun, is this enormous glowing ball of gas. It's basically a gigantic nuclear fusion reactor, and it is absolutely the powerhouse of our entire neighborhood. And speaking of that neighborhood, we call it a solar system. This is the star at the center, and literally everything that's caught in its gravitational pull. All the planets, all their moons, asteroids, comets, the whole shebang. Now prepare for a giant leap. Our solar system isn't just floating out there alone. Nope, it's just one of hundreds of billions of star systems inside our home galaxy, the Milky Way. Think of a galaxy as this vast, incredible island of stars, all swirling together around a common center. And that brings us to the final line of our cosmic address, the universe. This is it, the big one. It's everything. All the matter, all the energy, every single galaxy, and all that mind-bogglingly empty space in between. That's home. So we've got the address down, but can you really feel the scale of it all? To even begin to wrap our heads around the sheer size and the emptiness, we need to shrink things down a lot. Okay, this is where it gets really fun. Let's imagine we could hit the universe with a shrink ray, a factor of 10 billion to 1. On this new scale, our massive blazing sun is now the size of a large grapefruit. You could just hold it right there in your hand. So, if the sun is a grapefruit, what about us? What about Earth? How big would our planet be? Seriously, take a guess. Would it be like a marble? Maybe a golf ball? Or is it something way, way smaller? Like, say, the tip of a ballpoint pen? And there it is. The answer is just wow. On this scale, Earth is the size of the tip of a ballpoint pen. And it's orbiting that grapefruit sun from about 15 meters or 50 feet away. Let that sink in. Our solar system is almost entirely empty space. Okay, you ready to push this analogy even further? We're standing here with our grapefruit sun. On this same scale, how far do you think you'd have to walk to get to the next grapefruit, the nearest star, Proxima Centauri? You would have to walk from California all the way to New York, thousands of miles just to get to the next star. That really hammers home the unbelievable isolation of our little solar system in the vastness of the galaxy. Okay, we've got a sense of the insane distances involved. But here's where things get even weirder. Because space and time are fundamentally linked, looking out across those huge distances actually means you're looking back into the past. See, there's a speed limit in the universe, and that's the speed of light. Light from our moon? It takes about a second to get to us. No big deal. From the sun? About 8 minutes. But light from the Andromeda Galaxy, that light has been traveling for 2.5 million years to reach our eyes. And this leads to a pretty profound idea. Looking through a telescope is basically a form of time travel. The farther out into space we look, the deeper into the past we are seeing. We're not seeing those galaxies as they are right now. We're seeing them as they were when that ancient light first started its journey. So here's the little brain teaser for you. We see the Andromeda Galaxy as it looked 2.5 million years ago. So, when will we get to see what it looks like now? Well, the light leaving it now will take, you guessed it, another 2.5 million years to get here. We are always looking at the past. So far, we've talked about where we are, but what about what we are? It turns out the very atoms in your body have this incredibly deep connection to the lives and the deaths of ancient stars. It's not just a saying. We are literally made of stardust. Think of it like a cosmic recipe for making, well, you. First, the Big Bang cooks up the simplest ingredients, mostly hydrogen and helium. Then gravity pulls that stuff together to form the very first stars. Inside the fiery hearts of those stars, heavier elements like carbon, oxygen, and iron are forged. And then when those stars die, they explode and scatter all those new, richer ingredients across space. That material eventually comes together to form new stars, new planets, and everything on them, including us.
You probably feel like you're sitting pretty still right now, right? Well, that is one of the grandest illusions there is. The truth is, our planet, our solar system, and our galaxy are all on an unbelievable, high-speed road trip through the cosmos.
Let's just try to break down how fast you're actually moving. Right now, Earth is spinning on its axis. At the same time, we are whipping around the sun at over 100,000 kilometers an hour. But that's not all. Our entire solar system is on a 230 million-year orbit around the center of the Milky Way, and our entire galaxy is being carried along for the ride as the universe itself expands. So yeah, we are anything but still. After all that, I want to leave you with one last number, just to put everything into perspective. That number is 10 to the 22nd power. That's a 1 with 22 zeros after it. And that is our best estimate for how many stars there are in the observable universe. It's a number so big, it's pretty much meaningless on its own. But what if I put it this way? There are more stars in the universe than there are grains of sand on every single beach, on every single coastline, on the entire planet Earth. Just think about that for a second. Every beach, every desert, all the sand in the world, the stars outnumber it all. So I'll just leave you with this final question. After this journey, from realizing we live on a speck of dust orbiting a grapefruit, to understanding that we're made of the same stuff as a literal beach of stars, what's your perspective now? Does it make our home, our Earth, feel smaller and more insignificant? Or, in a weird way, does it make this vast universe feel a little bit more like home?